we're going to talk about lines in 3D. Okay, and what that means and so forth. All right, just back to the 2D world for a second. You can think of a line a couple of ways. All right, but I think it's almost, well, we'll discuss, right? So here's the line y equals 2x. Okay, and what I'm going to do is I'm going to write this line in parameterized form. Okay, so you might remember parameterizations. Parameterizations were new ways to represent functions sometimes, or the advantage of parameterizations is that you can easily represent a thing that's not a function, right? And it can circle back on itself very nicely and so forth. You know the parameterization for the equation of a circle, right? Do you remember that from last year, BC? What did x have to be? Cosine t, and y was sine t. And if you did that and you let t span from 0 to 2 pi, you can traverse the whole circumference of a circle of radius 1. So that was pretty nice. What's nice about that is it's much easier to graph in the calculator, right? Wasn't it? Because when you tried to graph a circle in the calculator, you had to do y equals plus or minus the square root of 1 minus x squared. You had to graph the upper half of the circle, the lower half of the circle. It's kind of cumbersome. Okay? All right, so what I'm going to do is take this thing and parameterize it. So it's sort of easy to do. We're going to let x be some third variable t. And then without too much work, if x is equal to t, what does y equal? 2t. All right? And there's sort of an extra requirement. You have to be a little more careful with parameterizations, and that is because we need to sort of specify what t is. Okay, so here's some more fun that you can kind of have. Like maybe I say to you, hey, t is in this interval. T is in the interval. Now, don't let that be confusing. This is t. This is supposed to be is an element of. It looks like epsilon. And because my handwriting's sloppy, it's not smaller. It should be. It's like making a c. You make a c and you put a little line in the middle of it. It's an element of this set. Suppose I make it of the element of the set 0 to 4. Okay, actually, you know what? We'll do better. We'll include the endpoints. So I will put a closed brackets on both sides. Okay? So here's what I claim. I claim that your old equation, the way you learned how to write equations of lines like y equals 2x, that this graph here that we're looking at right now is not the same as that graph. Why? What's different about that second graph compared to the one that I drew originally? Caitlin, I haven't heard from you today. Go ahead. That's correct. This one is not really a line, right? It's the best name for that thing. We could think back to geometry. The line segment. That's right. So we can figure out what the endpoints are. Plug in 0. If you plug in 0, x would be 0 and y would be 0. Okay. And if you plug in 4, right, you get x is 4 and y is 8. So here we go. So here's the point 4, 8. And the way I've described it, I've only described that line segment. Okay? Now I can fix that pretty quickly. What interval do I really want t to be a member of? Jerry? That's right. So I can fix that. I'm going to make a new equation, quote unquote, in green. X equals t, y equals 2t. And t is going to be a member of the set, negative infinity to infinity. And in that case, now I'll get the green line to match up with our old friend. No problem. Okay? All right. So that's called the parametric form of a two-dimensional line. You've done that plenty of times. Okay. We can actually write this thing a new way. We're going to write it in like vector form, is the way I'm going to call it. Okay, and what we're going to say is, we're going to start like this. We're going to say r of t. So I'm going to get you used to that notation. R of t is usually the name for a parametric curve. And we're going to study a lot of parametric curves and learn a whole bunch of things about them. And I think once I redefine this in parametric form, you'll see the 3D form of a line pretty quickly. Okay, so the way these things basically work is that you have some r sub 0, which you can think of as like a starting point. And then you do plus some number, I'm going to call it t, surprise, surprise. This is a scalar. Okay? It's literally using the word scalar like scale on a map, right? I can scale the size of the next thing that's coming. And I'm going to, I can call this whatever I want. I'm going to write it this way. Have you seen that vector notation before? It's like a less than, it looks like a less than a greater than, but it's really enclosing a vector. Okay? This thing here is called a direction vector. So this looks scary and stuff, but it's really not. When you look at the direction vector, what I'd like you to think is the following. A is really just my change in x, and B is really just my change in y. So you could really think of it as like another way to write slope. Okay? So what we'll do is tomorrow, well, just give you 1 second. We could do this real fast before we go. R of t is going to be the following. Would you agree there's lots of starting points I could pick for this line? What's sort of an easy one to pick? Jerry? Yeah, 0, 0 is an easy one to pick. So I'm going to write 0, 0 plus a scalar t times the direction vector. So if I want to get to the next point on the line, how much does x change by? And if x, well, let's say x changes by 1, what expected change will we see in y? 2. So this is called the vector form of a line. It's going to be very handy tomorrow when we go into lines in 3D. Okay? I hope you did well on your quiz today.